Hi there, my name is Paul Fisher from the University of Florida, IFAS Extension, and for our course on climate management, today I'm going to talk about our tool and our website backpocketgrower.org about measuring vapor pressure deficit. It's a topic that we talk about a lot more in the course, but basic principles are that in a leaf we have a lot of vapor pressure of water, and we have the air around those leaves are going to be drier. And if we can measure the leaf temperature and we measure the air temperature and relative humidity, we can calculate the vapor pressure deficit of the leaf. And if we're not measuring the leaf temperature and we assume that the leaf temperature is the same as the air around it, we can just do that calculation based on saturation vapor pressure at 100% relative humidity, which is what it is inside the leaf, compared with the amount of vapor pressure that we have in the air around it. So that's vapor pressure deficit, or VPD. We use it to, for example, program mist irrigation in a greenhouse. And we can have certain set points that we think are ideal. So here we've got the vapor pressure deficit in kilopascals. That's a unit of pressure going from 0 to 3 here on the axis. And we've got a evapotranspiration rate. That's the rate of water loss by a plant. And down in this bottom area with a low vapor pressure deficit, we'd have cool or moist conditions, a lot of high relative humidity. Up here we've got warm and dry air. And for plants, when it's really cool and humid, then plants don't take up a lot of water. And that can be good if we're, for example, propagating cuttings and we don't want the cuttings to dry out. But for a plant with roots, it doesn't take up much water, doesn't take up much nutrients. We run into nutrient deficiencies, more likelihood of diseases, for example. And when it's very warm, very dry, think desert conditions, then we're going to have wilting and stomata close and we lose production. And so we have ranges for different stages of crops. For example, in green, we have the range in kilopascals of VPD that would be ideal for production, in blue for propagating young plants, and down here in pink we've got high vapor pressure deficit numbers. In this table, got cool temperatures at the top, 15 degrees Celsius, 59 Fahrenheit, down to 40 degrees C, warm at the bottom, 104 Fahrenheit, and dry air, low relative humidity, 25% on the left, going through to 100% relative humidity on the right. And won't go into these details very much, but they're described in the tool and in our courses. But basically we want a low VPD for low water loss for propagation. We want a moderate VPD for water uptake, but not stressing the plants. And most of the time, unless we're growing a succulent or cactus that's really adapted to conditions of very warm, dry air, then we don't want these high VPDs or we'll get drought stress. And so what we'll do next is we'll go into our calculator on backpocketgrower.org and we'll talk about how to calculate vapor pressure deficit.
To use the VPD app in backpocketgrower.org, go to backpocketgrower.org in your browser, and if you want to, you can change the language depending on whether you're on a laptop or a phone. It may look slightly different, but there's settings and you can change the language here. Select Tools either here in the menu or down here in the picture. And you'll see that there are a variety of different topics. Go into Climate and choose the Vapor Pressure Deficit tool. You'll see a short note with sponsors, and now you're within the calculator for vapor pressure deficit. You can get some background information like the graph that we're already looking at. And you can then change some settings. So in this case, let's use Celsius units and kilopascals. You could choose something else, for example, millibars here. We'll use an example where we've got 45% relative humidity and an air temperature of 28 degrees Celsius. Click on calculate and it will calculate the vapor pressure deficit for you. Here it's 2.1 kilopascals. So that would be considered a high VPD, which would mean rapid water loss. And it also has some other useful information in here, such as the dew point's temperature. The temperature at which you'd see condensation would be 15 degrees Celsius. If you have the information with a leaf temperature sensor, you can enter it in here. So for example, if we say that the leaf temperature is 25 degrees Celsius, then it will recalculate vapor pressure deficit based on that information. And it'll do recalculation here. So there's a difference with air VPD if we don't have leaf temperature, and we'll calculate leaf VPD if that information is known. And so because the leaf temperature is cooler, in this case 25 degrees Celsius, then the leaf VPD would be 1.5 kilopascals. So that is the VPD calculator in backpocketgrower.org.